Jai Hind. We are going to continue our previous lecture on predicate logic problems. In the last lecture, we have seen the clause form. What is the clause form? That we are going to use today. Resolution principle, again we will have a revision and then we will use it in example. Then unification and a main example that we are continuing from our previous video. So first one is the clause form. What is the clause form? Clause form is the sentence. The clause form is the form of sentence in which we use only two operators, negation and or. So here we are having two statements, two proposition. One is x or y and second is not of x or z. So if we see these two statements, in these statements only we are having negation and or operation. So these are in clause form. Then let us revise the resolution principle as we have discussed last time. What is resolution principle? If we are having two propositions just like this, what are the proposition? One is having x or y, another is not of x or z. So what is the form? One proposition is having x in non-negated form and the other proposition is having not of x. It means negated form of x. So if we are having these type of two proposition, then we can apply resolution. In resolution, these terms will be resolved and what we will get in answer? The remaining terms from both the statements. What are the remaining terms? One literal y from here or and one literal from the second one. It means all the terms except the literal which we have resolved. What we have resolved, which is having in one place x and other not of x. It means negation of x. So this is the resolution principle that we are going to use. These are the steps we discussed last time. Whatever is the proposition given, whatever statement is given, that can be converted to clause form. And these are the 9 steps that we discussed last time. I am considering here again on one slide because when we will do our example, we will need to apply all the steps here also. So we'll start with eliminating implication, then we will reduce the scope of negation. We will standardize the variables apart if the same name variables are used. Then we will move quantifiers to the left. Then we will do this columnization to eliminate the existential quantifiers. After doing that, we will left with only universal quantifiers. So we will drop all the prefixes which are actually the universal quantifiers. Then after removing implication and quantifiers, we will move towards removing the conjunction. How the conjunction is removed? That is done with the creation of conjunction of disjuncts with help of distributive law. Then we will remove conjunction and we will create separate clauses. And now at last again we will standardize apart, means if we will have the propositions with the same variable name, we will rename those with different names. So this up to this point we have discussed last time. What unification is? Unification will also be used in running of the programs in derivation inferences using resolution. What is unification? Unification is we are given some variable. So can we unify some name, some value to this variable? Let us understand this example again. In this, what is given? If X is a seafood, then John likes X. Now, when John likes X, when it is a seafood, and we are given one fact that shrimp is a seafood. It means we can give this value of shrimp to X. Shrimp value can be assigned to X. From there, what we will get? We will get the proposition, if shrimp is seafood, then John likes shrimp. So we can conclude that John likes shrimp. Okay, so this is unification. It means some value which is given in the fact that can be assigned to the variable name which is same. For example, here seafood. So if X is seafood and I'm given that shrimp is seafood. So I can unify X value with shrimp. Okay. So this is our unification. So this we have done in our last lecture also. Now let us continue with our example. So we have taken here this example, resolution example. So what are the statements given? Firstly, that will be converted to symbolic form. Then we will see the symbolic form. That symbolic form should be in clause form. So we have we have gone through the 9 steps. We will convert those to clause form, and after having all the sentences in form of clausal form, then what we can do, we can apply resolution and we can find out the given thing is inferred or not. So what is to be proven here? That is John likes peanut. Now let us consider all the statements one by one. So what is first statement? John likes all kinds of food. It means we have to find out all kinds of food. So when we have to represent all kind, it means for all. So which quantifier is used? For all. So John likes all kind of food. It means if I take some variable, let me say X, for all X, if X is a food, what I said, John likes all kinds of food. It means if X is a food, then John likes X. If X is a food, John likes X. Okay, this is my first statement. Now, if you see this statement, in this we are having one quantifier X and one implication. So what are our steps? Our step says that firstly, at first hand, remove the implications. How do we remove the implication? With equivalence. P implies Q is equal to not of P or Q. That is the logical equivalence. So let us convert, change it to the OR form. So it is equivalent to for all X, not of food X, or John likes X. So this is our first step. What is the second step? Second step is reduce the scope of negation. We have already applied negation on the predicate directly, so that is not required. Again, if we say, are there two variables? No, there is only one variable, so no need to standardize separately. Then move all the quantifiers to left. Already we are having the quantifier to left. After moving quantifiers to left, we have to remove the existential quantifier. In this, there is no existential quantifier. Okay, so that step is also not needed. Then after doing all those, we can drop the quantifiers. What is our quantifier left here? That is for all X only. So we will simply drop it. So what we are left with, it is equivalent to not of food X or John likes X. Okay, now if we see, we are only having not and or. So it is the clause form required. The other steps are regarding removal of conjunction, but that is not required here because we do not have any conjunction here. So this is our first clause. So let me write it as 1. This is my first clause. What is my first clause? Not of food or John likes X. Okay. Now second statement. What is second statement? Second statement says that apples are food. Okay. So it is simple one. Food, apple. So this is already in, this is single predicate. So it is already in clause form. So let me denote it. Next is chicken is food. So food, chicken, Again, it is already in normal form because there is no other operator. So let me denote it 3. So I have got 3 clause form proposition till now. Okay, now third one. What is third statement? Third statement says that anything anyone eats and is not killed by is food. So what does it mean? It means we need quantify. Why? Because we are talking about anything, anyone. It means we can take any value of food and any person. So we will use here universal quantifier because anything is allowed. Okay, if something is allowed, then we write there exists. But here, what is the point? Anything is allowed. Okay, so what I need to do, anything anyone eats. So let me take one variable for the person who is eating and one variable for the thing which is to be eaten. Okay, so let me write it for all x, for all y. So what is said here? Anything anyone eats and is not killed by. It means if a person X eats the thing Y, anyone, any person, if eats anything, okay. So let me say X eats Y and after eating this is not killed by. It means not killed by X is not killed by Y. Okay, then Y is food. X eats Y and X is not killed after eating Y. Then Y is food. This is written in our statement. Now see what we need to do. We want clause form. So what we will do? We will do all the steps one by one and we'll stop where we will get the clause form. Okay. So in this, if I see, I have one implication. So firstly, the implication will be removed. So what I will get? I will get for all x, for all y. Now, what is this left hand side? This is P implies Q. So not of eats xy and not killed by x is not killed by y, okay, or food y. So what I did, P implies Q is equal to not of P or Q. So I got this statement. The second step is, what is the second step? Reduce the negation of, reduce the scope of negation. So if I see not here, I can apply on this using De Morgan's law. So what I'll get? For all x, for all y, not of eats xy or not will be double negation, so it will be cancelled. So it will be killed by x comma y or food y. So if we see this here, we are getting now quantifiers and we have removed the implication. Now next step is change, standardize apart. But here both the variable names are different, so that is not botheration here. So simply move all the quantifiers to left that are already on the left. Then do solmization to remove existential quantifier, but there is no existential quantifier. So simply we will drop the quantifiers. Okay, so let me drop these two quantifiers. So what I'll get here in clause form, not of eats xy or killed by xy or food y. So this is my fourth clause form, fourth statement. Okay, now next one is Bill eats peanut. Okay, so eats Bill. What we have taken? X eats Y. It means person first. Eats Bill. What? Y. That is peanuts. And Bill eats peanuts and is still alive. Is still alive means Bill is not killed by eating peanuts. So not killed by Bill's, peanuts. Now, if we see this particular proposition, in this there is no implication, so no need of requirement of removing implication, no quantifiers, so no more change of quantifiers and their columnization. Okay, directly we will go to the steps for conjunction. So we are having conjunction here. So conjunction means P and Q is true. It means P is true as well as Q is true. So simply we will segregate. So what we will have here, we will got two proposition corresponding to this. Because how conjunction is removed? By taking the two conjuncted propositions separately. Okay, so let me take these separately. First one is eats Bill peanut, and second one is not killed by Bill, peanuts. Okay, so let me call these 5 and 6. 5 is Bill eats peanut and 6 is Bill is not killed by eating peanuts. Okay, now next statement. What is next statement? Next statement says that Sue eats everything Bill eats. Okay, it means if there is something X which Bill eats, then Sue also eats that. So let me take for all X, if Bill eats X, then Sue also eats X. Everything Bill eats, if Bill eats X, then Sue also eats X. So again we will convert it to clause form. What is there in this proposition? That is implication. So what I'll do, firstly I will remove the implication. So what I'll get, for all X, not of eats Bill X or Sue eats X. Okay, there is no need to reduce the scope because already it is directly on proposition. Then we will see that the quantifiers are on left. No standardization of variables are required because there is only one variable X. Okay, now we will move all to left. These are already there and there is only one quantifier, that is for all S, universal quantifier. So no need of columnization, we will simply remove it. So this is my next statement, that let me call it 7. Okay, now what is to be proven? John likes peanut. It means likes John peanut. This is to be proven. Now how we will prove it? We will prove it with, this is already in clause form, so we will not apply any step here. So what is to be proven? We have to prove it, so we will use the method of resolution refutation. In resolution refutation, actually we check the contradiction. So what we will do? We will take negation of this. What is to be proven? We will take negation of this. We will take it as 8th one. Okay, now we will apply resolution rules, and if we will get nil in answer, it means our database is inconsistent. So what has made our database inconsistent? That is negation of likes John peanuts. So when negation makes the database, the fact base inconsistent, it means the assumption we have taken is wrong and John likes peanuts. So let us check these, how to apply the resolution refutation. So now we are having 8 clause forms. First one is saying not of food X or John likes X. Second is saying apples are food. Third, chicken is food. Then Fourth one is not eats XY or killed by XY, food Y. Okay, now next one is not killed. Bill eats peanut. Next is not killed by Bill, peanuts. Then not of eats Bill, comma X, or eats CUX, not likes John, peanuts. Now we are having all these propositions. So now finally we will standardize all apart. Okay, so what we can see here, Y I think we have used only here. So what we have used multiple times, that is X. So let us standardize all the variable apart. Let me take it X1. Okay, after that we are having X here. So let me take it X2. Y is occurring only once here in this statement. In this there is no X, no Y. In this we are having X. So let me write it as X3. So we are having X as 3 places and Y only at once. So we have taken all the different variable names. Okay, now we are having all these proposition. So what we have to prove? We have to prove not likes John, peanuts. We have added it because we have to prove that John likes peanut. So can we resolve it with anything? So if I see 8 and 1. In 8, I am having not of likes John, peanuts. And in 1, I am having John likes X. It means I can resolve 1 and 8 and I will get by unifying X1 with peanuts. I will unify X1 with peanuts. So let me do 1 and 8. 1 and 8 has been resolved. What I am applying? Resolution on these propositions. And what I did? I unified X1 with peanuts. Peanuts. So what I got here? John doesn't like peanut and John likes X. So these will be resolved. What I'll get in answer? Not of food X1. Not of food X1. X1 is unified with peanuts. So not of food peanuts. Okay, let me call it 9. From 1 and 8, I got this after resolving and unifying X1 with peanut. Now I am having not food peanuts. Now see, not food peanuts. So if I see this, not food peanut can be resolved with food Y, that is 4. So if I see, take 4 and 9, okay, and Y I take as peanuts. So from 4 and 9, unifying Y with peanuts, what I am getting? This term will be resolved, food Y with not of food peanuts. What will be left? What I will be left with? Not eats X2 comma Y. So not eats X2 comma Y. What is Y? Unified peanuts. Or what I am getting here? Killed by X2 comma Y. Or killed by X2 comma Y. Y is what? Peanuts now. It has been unified with peanuts. Okay, now let me call it 10. Now if I see what is there? Killed by X2 peanuts, and in one place I have not of killed by Bill peanuts. It means 6. So X2 can be unified with Bill. So from 10 and 6, what I can take? X2 can be unified with Bill. Okay, so what I was having there in 6 was not killed by Bill peanuts. Okay, so I will take it as Bill. So what I will get here, only this. This term will get resolved. Let me take it as 11. So what is my 11th proposition? Bill doesn't eat peanuts. Now, if I take one of my previous proposition, that is 5, what is given here? Bill eats peanuts. So, if I take 5 and this, Bill doesn't eat peanut. It means from 5 and 11, I am getting doesn't eat Bill peanuts, and one place I am getting Bill eats peanuts. So what I am getting? Nil here. So I got nil after resolution. It means it is refutation, resolution refutation. It means my assumption was wrong. My assumption was wrong. Okay. So what was my assumption? My assumption was John doesn't like peanut. So it was wrong. It means John likes peanut. John likes peanut. So this was to be proven. So this way we can apply a resolution to prove one conclusion from the given premises. Okay. So we have discussed what is the base requirement, the resolution principle we should know, and we should know unification, and any statement which is given can be converted to clause form, and clause form is required to apply resolution. So in this particular lecture, we revised our resolution unification concept and the conversion to clause form concept from our previous video, and in this particular we have done our predicate logic problem solution using resolution refutation. Thank you. Jai.